Now that we have defined what positive and negative correlation means, we're now going to talk about how to determine how strong of a correlation they have. And this is known as the correlation coefficient. So like I said, the correlation coefficient determines the strength of our correlation. And it's denoted by an R. The correlation coefficient is a unitless measure, and it's between -1 and 1. The closer you are to either -1 or 1, the stronger of a correlation you have. If you have a correlation of exactly 1, that's a perfect positive linear correlation. This means that all of your points actually do lie on a straight line. If your correlation coefficient is -1, you then have a perfect negative linear correlation. Once again, all your points are going to lie on a straight line. And if you're right in the middle with a correlation coefficient of 0, that means that it's completely random. There is no correlation whatsoever. And the correlation coefficient's very nice because if you manage to switch your x and your y variables for whatever reason, your value of r remains unchanged. So you'll still see the same correlation coefficient. In addition, if you convert your variables to different units, your value of r is still going to be unchanged because, once again, we have it's unitless, so we don't have to worry about that. And it's very important to note that correlation does not imply causation. Just because you have a correlation coefficient, that just tells you that they are correlated, but not that one causes the other. There may be lots of other things going around, maybe some background things that we aren't immediately aware of, or it could just be random. Here's our formula for the correlation coefficient. N is going to be the number of things that you have, the total number of data points. X and Y are your variables, and this symbol here means sum. So essentially this means we're going to multiply all of our x variables by the y values and then add them up. And then we'll multiply that by the number of things we have. We'll subtract the sum of all the x values times the sum of all the y values and then divide by the square root of the number of values times the summation of all the x values squared minus the summation of all the x values and then squaring. And then we repeat for the y variables. So you can see that this is really complicated to actually find. And usually we rely on computers and everything and calculators to find this for us. So I'm not going to do a specific example of finding it, but it is just important to have an understanding of exactly what the correlation coefficient is.